Okay, we're going to go ahead and start with 11 through 20 of part 1 of your semester review exam. Before I actually start, I'm going to go over a couple of housekeeping things first. In the meantime, if someone can go ahead and pass out the packets, the review packets, to the appropriate people. I just want one person. Actually, let's go ahead and get Dahlia. Dahlia Davis, if you're there, please go ahead and get the packets. If the substitute doesn't know where the packets are, I have located periods 1, 2, and 3 on my black cart where I usually work to project on the screen. So if you pay close attention, there should be a stack on there which has students in second period. That is your stack right there. So go ahead and pass out the review packets to the appropriate people. For those that weren't there yesterday and didn't get a packet, I do have blank packets on in that same location right on top of my hole puncher. So again, while Dahlia is passing out the packets for those that were here yesterday, for those that weren't here and need a packet, go ahead and grab one. It's right in the same location on top of my hole puncher. Also, I will not be there probably up until fourth period, so I should be back for the rest of the day. So in case you need me throughout the day after fourth period, or also in case you need me after school, I will be here for tutorials. Next thing is, obviously, I have a substitute. Second period hopefully has learned their lesson in regards to my subs. Again, if I get any kind of negative note or negative review, then you will have to face the consequences, and instead of giving you the actual midterm, I will give you something else completely beyond difficulty level from what the midterm is at the moment. So make sure that you tell your classmates to behave. For those that feel frustrated from last time, make sure that your classmates behave. Okay, so at this point, everyone should have already gotten your packet. Let's go ahead and start off with number 11. So if we take a look at number 11, it's stating find the angle between the two vectors. So this is a vector question. We have vector u and vector v. So I'm going to steer away from IJ notation because it's better to work in component form. So we're going to take the component form of u and the component form of v. The component of u is cosine of pi over 4, comma, negative sine of pi over 4. Why negative? Because this negative right here. Likewise, the component form of vector v is cosine of pi over 3, comma, sine of pi over 3. It's going to be positive. So let's take a look. Okay, and that's what I've written right here. I'm going to actually, I see a mistake, so I'm going to change it. My mistake was right here. Okay, so while I'm erasing and fixing my mistake, go ahead and write the u vector. As you can see, I have actually taken just what's in front of each letter, the I. So what's in front of the I is the cosine of pi over 4. What's in front of the J is negative sine of pi over 4. And then I take the values. If you don't have them memorized, you can go to your unit circle. Cosine of pi over 4 is radical 2 over 2. And sine of pi over 4 is also radical 2 over 2, but then let's not forget the negative that's in front. Then we have vector v, that is cosine of pi over 3, comma, sine of pi over 3. So if you have your unit circle memorized, you should know that the cosine of pi over 3 is 1/2, and sine of pi over 3 is radical 3 over 2. If you're not sure, let's go ahead and take a look at your unit circle. Here is pi over 3. Cosine is the x-coordinate, which is 1/2, and sine is the y-coordinate, which is radical 3 over 2. So I was correct. Okay, so we have 1/2, and we have radical 3 over 2. Perfect. Okay, so I have changed my u and my v vector into component forms. When we're trying to find the angle between vectors, remember that has a lot to do with this formula right here, which you have just recently been tested on. Cosine of theta is equal to u dot v over magnitude of u times magnitude of E. And because I'm using Paint, this might be a little bit sloppy. I think it's quicker that I use Paint versus me using the actual equation editor on Word. So please excuse my sloppiness for this one. Alright, so it seems that I first need to get U dot V, U dot product V. So that's exactly what I'm going to do. So remember, dot product really is first component times first component, second component times second component, and then you add them together. So let's take my first components. So we have, and I'm going to go ahead and write them down here, U dot V is equal to first components times first component. So radical 2 over 2 times 1/2. And then I'm going to always add that with my second component times second component. So I have negative radical 2 over 2 times radical 3 over 2. All right, there we go. Okay. So now all we need to do is clean this up a little bit. So let's see, we really have, this is equal to, remember top times top, so radical 2 times 1, anything times 1 is itself, so we have radical 2 over, and bottom times bottom, 2 times 2 is 4. Plus, now we have the inside here, positive times a negative is still a negative. And all we do with square roots with different numbers underneath is just multiply them and keep the square root. So 2 times 3 is 6. And then, of course, bottom times bottom, which is 4. So in other words, this one really is radical 2 minus radical 6 all over 4. Okay, so that is U dot V. Now, in a minute, we're going to go ahead and do the magnitude of each one. Okay, so let me write this down right quick so I won't forget. U dot V is equal to radical 2 minus radical 6 over 4. Okay, so now I'm going to find the magnitude of each one. So before I forget, I'm going to write this down also. Radical 2 over 2, negative radical 2 over 2. And V is 1/2 radical 3 over 2. Okay, so I'm running out of space. I'm going to go ahead and get a new one. All right, so we found U dot V. Now let's find the magnitude of U. Magnitude of U is equal to first component squared, so radical 2 over 2 squared plus second component squared, which is negative radical 2 over 2 squared. Okay, so remember for this one, when I square a negative, it's still going to be positive. So we're good to go here. So I have, this is really when you have to distribute this 2 to both top and bottom. So radical 2 squared really just leaves me with 2. And 2 squared gives me 4. Same thing for this one. I have 2 over 4. Okay, so when I add 2/4 plus 2/4, I get 4 over 4. Or in other words, 1. And then if I take the square root of 1, that's equal to just 1. So my magnitude of U is 1. Now I'm going to do my magnitude of V. Okay, so let's go ahead and find magnitude of V. And it's going to be same concept. First component squared plus second component squared. So here we go. Magnitude of V is 1/2 squared plus radical 3 over 2 squared. Okay, so remember we're going to distribute that power of 2 to both numerator and denominator. So here 1 squared is 1 over, and 2 squared is 4, plus, now remember when I square a square root, I just get rid of the square root, so I really have just 3 over, and I distribute that 2, so that's 4. 1/4 plus 3/4 is equal to the square root of 4 over 4, or in other words, equals to the square root of 1, which is indeed 1. Okay, so it seems that we have magnitude of u is equal to 1, magnitude of v is equal to 1. Alright, so what really is going to happen then is this. Let me go ahead and scroll down. So I really have cosine of theta is equal to u dot v. What did we get for u dot v? We got radical 2 minus radical 6 all over 4. And we're going to put all of that over 1. And that still is going to give us radical 2 minus 6 minus radical 6 over 4, because anything over 1 is itself. Okay, so I don't want cosine of theta, I want just theta. So that means I'm going to have to take the inverse. Okay, so once we take the inverse, I'm going to get a new one. So I have theta is equal to inverse cosine of all of that good stuff. So radical 2 minus radical 6 over 4. Okay, so then we go ahead and find our angle. Let's see, I have a calculator here. Mine is a little bit different from yours. Mine, it does not have the fraction mode, so my keystroke for alpha y equals enter does not work. But the first thing I'm going to do is change it to degree mode. And then I'm going to basically do it my own way right quick. I'm going to take the square root of 2, and I'm going to store it as letter y. And then I'm going to take my square root of 6, and I'm going to store it as my letter z. So basically what I'm going to do is I'm going to say second cosine, that gives me the inverse, and I'm going to say y minus z over 4, close my parentheses, and I should get my angle, which happens to be 105 degrees. So this should equal your angle in between the two vectors, which is 105 degrees. And that is my solution for this one. Okay, number 12. Let's take a look at number 12. Number 12 says find the area of the triangle. This is basically an oblique triangle. So let's go ahead and just draw an oblique triangle. It doesn't matter which way you're drawing it or which way you're labeling, as long as you're consistent. So we have some oblique triangle. Okay, I will call basically this one big A, big B, and big C. Across from big C is little c. Across from big B is little b. And across from big A is little a. Okay, this piece of info is saying find the area of the triangle. So this one is basically saying that A is equal to 7. C is equal to, little c is equal to 3. And big B is equal to 63 degrees and 10 minutes. Okay, so let's see. We have side A, side C, and angle B. So let's check our formula for areas. And remember, I will give you the